Okay, let me move it.
This right here. This is what they'll find. Tap on it and we can start playing with it.
Okay, let's get this. So I'm
It's
gonna
very,
rotate it.
yep, there we go. And what he has there, there's an icon going from left to right, is what happens when four bubbles meet. I took actually the actual curved triangular pieces and I put four of them together based on universal ratios. And this is what it generated. We bring that closer.
Yep.
So everybody can and look at it from not just the top, but from maybe a 60-degree perspective, a little more and closer, just so they can see it. What you're looking at right here, if you'll rotate it, this is the point where bubbles meet. This is the negative space that they cannot compress. This is what we would call dark matter. This is the proton, the geometry of hydrogen itself. And we'll see that it has 8 poles, it has 4 contractive poles, and that's where it concaves in, and it has electricity seeking a higher pressure condition will cause a cavity, and magnetism, unable to maintain its electrical potential, ends up spinning off of the vortices.
So real quick, brother, when you say 4 bubbles, you're literally saying that there's a sphere here in this space, and this is just the negative space when 4 spheres are literally coming together. This is the space that's left in between them.
Yes. Yes.
Brilliant, 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 brilliant. You know, because I know people say bubbles. 4 bubbles, what are you talking about? Uh-oh, sorry.
Go ahead.
You know, and that's what people.
Go ahead.
Okay, I'm sorry. Just real quick. People are trying to understand when you say bubbles, you're literally talking about 4 spheres. And like you said, you can see this concave. It's like you could put a sphere here, you could put a sphere here, one on the other side, and then one beneath. And this is the this is the actual shape that you're going to get. And one thing really quickly, and then I'll shut up. But one thing when I was looking at this earlier, I literally see I see 3 circles on the ground here. You got this circle here. I don't know if you can see my pointer. Circle here, a circle here, and a circle here. These are 3 of the bubbles, 3 of the spheres right there. And you put another one underneath it and you got your 4.
And that's what the flower of life was trying to leave and tell us, 10,000 years ago, by whomever advanced civilization told us that these would be the fundamentals, because everything expands as a sphere and contracts in geometric form. These contractions are the result of expanding waves that hit the edge of the universe and come back. And it's periodic and regular enough to where we have this structure that we call hydrogen, the proton.
And when you say periodic, that's the periodic part, right? It's just in intervals, predictable intervals.
Yes.
Nice. Should I go to the next one?
Yep, go to the next one. The one next to it was, and I called this one a tetryon. And the next one, and I patented these things because I wanted to make sure that it was understood where they came from. Because a lot of times our work is not attributed to us.
Right,
but
like George Washington Carver, he didn't want the patents for his stuff.
Yep. So like that last one that we saw, it had 4 equal contractive poles with 4 repulsive poles, 4 electric poles, and contractive electric poles, centripetal electric poles, and 4 magnetic centrifugal. Now, this is what happens when 8 bubbles meet. This is the negative space where 8 bubbles have met. But you'll notice it has 8 contractive poles. If you spin that around, you see 1, 2, 3, 4. And around it, you'll see the same. You can go slightly underneath it. Yeah, you'll see the other 1, 2, 3, 4.
Sorry.
If you do that. But yeah, just spinning it around it. Just continue turning it to the left. Yep. You'll see that there's 4 poles there, 4 contractive poles. So there's 8 contractive poles, electric poles, but only 6 magnetic poles. Only 6 points where it's discharging. Now, wouldn't that sound like the strong nuclear force in comparison to the weak nuclear force of where it's an equal and it's 4 equal contractive poles and 4 equal repulsive poles? Well,
so when you talk about the 6, you're talking about these 6 points here, right? 1, 2, 3, 4, 5.
Yep, each vortice is
6.
a magnetic pole. It's a discharging pole.
Uh-huh.
It only has, so it has a greater electrical potential, a greater electrical and attractive potential than a repulsive potential. Well, let's see what happens when 6 bubbles meet. If you go to the very next one, right? Yep, right there. Wow, look at what's happened. This thing has now this hunting, which is in the center, has attracted these 2 lesser attractive components. This looks just like a photon, and you could see those big swipes where 6 bubbles or 6 fast moving bubbles are occurring. 1, 2, 3, and keep turning it, and you'll get all 6 of them. Each of those huge, and you'll see it's a combination, and this is a step up transformer. You're stepping up from 3 sides, 1, 2, 3 from these, from the tetraons that's on the ends of it. You're stepping up from 1, 2, 3 up to a 1, 2, 3, 4 on electrical potential with the Huntian, and then it steps back down to a 1, 2, 3. Well, that's everything that we see with our mechanical and our electrical transformers, a step up and step down transformation. But
Wow.
the stable structure. So let's see what happens when 12 bubbles.
Okay, so real quick, you said with our transformers, you're literally talking about the electrical transformers that are on the power lines, stepping up and stepping down energy.
Yes, a step up and step down transformation. Everything behaves that way.
Huh.
So here's the, I say is here is the strong and weak nuclear forces. And now this is what happens when 12 bubbles meet. And what this ties into is what we were saying under different motion and pressure conditions. You get a different crystallization. Here's another stable structure, but it still has 4 electrical potentials that hasn't been accounted for in the Huntian. Still has 4 unaccounted for. The points at, if you go to the center, point your pointer to the center, rotate it to the right a bit. If you rotate it to the right and zoom in a little bit, yep, and zoom in and take that pointer right to that center point, to the center, yep, there. That's the unaccounted electrical potential, and it has 4 of them. So this thing still is attracting things, but it's a stable structure. And then, so you go to the very last one. So you can see, and I didn't have to break any rules to make that.
Right.
And
so you're constructing these. You're constructing these on solid mathematical principles.
Universal ratios.
Wow.
So now you look at, now this Huntian, all of its electrical potential has been accounted for. So you would not be able to distinguish this from the background, from the rest of the universal background, because it gives off no electrical potential.
Wow.
And so this is the Bose-Einstein condensate, when something becomes indistinguishable from the fabric of the universe. This is balance.
So Terrence, somebody who's a mathematician, a physicist, electrical engineer, chemical engineer, seeing this, their mind should be getting blown right now, right?
Yeah, or they should get turned on. And I look forward. I'm at the point now where I'm ready to war. So I challenge any chemist, any physicist, any astrophysicist, any cosmologist, any biologist, anyone within the fields of science to come and challenge me. And these are proofs. This isn't theories anymore. Theories are written out and need to be proven. These are geometric proofs.
Right.
These are
this is proof of concept right here.
And what you're looking at is electricity. These are the natural folds of electricity. Now, they have other supplemental folds that ends up occurring, but this is the highest point of contraction where everything is held in and there's balance. Now, I want to show the supersymmetry of these with that other video that I sent you of the structure I've actually made by hand. This is what I've sculpted.
Okay, here we go. So it's the with the clear plastic pieces.
Yes.
Okay.